All right, so welcome back to the lesson 06, and here we would like to discuss about the furthermore properties of the fluid with respect to the density. So till now we have discussed about the attributes of the substep simulation rate scale by keying down certain elements, certain attributes of the fluid shape nodes, which is the auto resize margin. I've told you this is very important settings. And right now we are at a very low resolution because it's only at 60. So that's why we are not wondering about the max resolution. So, this is the resolution which, if the sum total of all the fluids, like, from the X, Y, Z, get equivalent to 200, then they won't able to simulate. Actually, the case is that if I need to, let's say I'm gonna utilize that thing to the 50, okay, and if I start playing the timeline, you may gonna see that at this point of time, when the reaction has reached its value, that means 50 has been allotted to the resolution X, resolution Y, and resolution Z. So you could see that 56 plus 34 plus 57, which is 150. So the max resolution that could be utilized with respect to the auto resize of the container could go maximum by 150. I think so they may could give you some better um, understanding if they could have listed down some little bit more better UI to understand the max resolution. But no problem, at least now we are getting into that. You could see that the fluids are consistently moving, but there is no utilization of the auto resize because the max resolution has already been reached. So to avoid that, we would like to go with the 450, and this we would like to give 450 only when we going to simulate the base resolutions with a very very high rate, that is approx 250, or you could say 225. In my case, the reaction will going to be 200, and I've also created another reaction of the same files in which I've used the base resolution to the 300. I'm going to discuss that thing in the end of the lessons, okay? So till now we are good to go with this value. So max resolution is set to 450, it's not a problem. Now we're going to come back to the content details. Let's say we're going to talk about the density sections first of all. And in this reaction, um, what I'm doing it and why I'm doing it, I'm not going to utilize the buoyancy too much. Reason why? Because this is a very aggressive reaction. No doubt the missile has dropped on the floor. There's a very high impact of the reaction. There's very high impact of the explosion. But the problem is that if we're going to utilize the buoyancy, the density buoyancy, I'm going to end up with the, you know, mushroom shape, and, there isn't any utilization for the turbulence. I mean, I cannot able to use the disturbances inside that. No doubt the gradient force is pretty much good, and it'll gonna, pushes the fluid in all over the XYZ vectors, but it cannot become the replacement of the temperature turbulence. So that is the reason why, my whole reaction is completely based upon the temperature. Okay. But no doubt we need to have a little bit more value tweaked. So for the buoyancy, I'd like to go for 2.5. Obviously, this reaction need to give an end, so the dissipation will going to be 2 approximately, since it's a very heavy reaction. So obviously, it'll gonna settle down with some lighter version of the dust. So could be possible only if you have the dissipation. No, we're gonna not talk about the diffusion, pressures, and all this. I have already told you that the pressure and the pressure threshold we're not going to utilize, since we are again utilizing the particles with respect to uh, the speed that we have set to the zero point 0.5 with respect to the inherent velocity. Okay, so there is no need for the pressure and the pressure threshold. The noise, I would like to go for 0.125, since this is a very important attribute. Without this, it will be very difficult for you to grab the details inside the fluids. Since we're going to set the graph to the opacity, which is, under the shading menu, you could see the output graph will going to be the density base. So that's why a little noise is very, very important to give some extra details. Now the most important thing is that the gradient force. We like to go with, let's say, maybe 65, or let's say 75 in the beginning. Let me just key that up, and I'm just going to disable that up again. And now let's say at frame 60, probably this value will going to come back to maybe 20. Okay, because it's quite obvious and quite apparent that the gradient force the same cannot be with the same magnitude throughout the reaction, because most of the energy will going to be burst out at the beginning of the frame. So let's say at least for 3 seconds or 2 seconds, it will gonna have a lot of push in the voxels all around the x, y, z, but it will gonna get calmed down. Okay, it may could be like that. I'd like to give the value of 10. Okay, that's pretty much good. Now, I guess the density section is being filled. Not a problem. This is the maximum settings we would like to tweak. Now, coming back to the velocity section, again, this is very important. So what I need to do in that case, again, the swirl that is responsible for the vorticity or the rolling of the smoke. We also acknowledge that this is not the gasoline explosion in which the rolling will gonna be too much high, but still we required some important settings of the swirl. So let's just do one thing under the velocity section, like to give it 8 with the initial settings. I'm gonna put that key, and let's say at frame 35, no, let's say at 60, we would like to give just half value. Okay, so quite obviously, the swirling and the vorticity will not going to be the same throughout the reaction. It is maximum in the beginning and will start losing the energy as the reaction proceeds with respect to the time. Coming back to the turbulence. All right, so this turbulence is basically the property of the air or the wind that it'll gonna disturb the motion of the moving fluids. So the strength will remain 1. Since this reaction is quite bigger, we are utilizing the higher number of particles, higher voxels, so it just requires some higher versions of the turbulency. Rest attributes, let's say, remain the same frequency and the speed is 0.225. That's pretty much okay. All right. And I guess so. This is the final things regarding the density, velocity, and the turbulence. Now I'm gonna again enable the fluids and like to see what exactly the changes that you are getting. If you're noticing carefully, the change what I'm observing here, which is, obviously I do acknowledge, which is very, very difficult to observe. The gradient forces are now started acting upon. You may could see that with some few clicks, and at frame 12 only, you are just started receiving the shapes. But I also understand the fact that there are, pretty much issues which will fairly gonna address once we started building our you can say the graph. The reason why I'm not just moving quickly, because I need to come back and I have to explain each and every attribute very carefully so that it will be easier for you to grab the things. So I guess the basic things are already being done, and now we would like to jump up to the another great section, that is the temperature. Okay, so I'm taking pause.